Well, hello everyone. Welcome to the season opener of the Stormwater Sessions live series. My name is Ben Curtis. I'm with the Iowa Stormwater Education Partnership, and I'll be proctoring today's webinar. Just a few housekeeping notes, and then we'll jump right into it. I think it said it at the beginning, but everyone is currently muted. If you're calling in via telephone, just please mute your computer audio. You muted already, but we've ran into feedback before this way, so just heads up with that. If you have any questions during the webinar, type them into the chat box or the question box, whatever is easier for you. I'll be watching that chat during the presentation to make sure that we'll answer your question after the presentation's over. A little different this year than last year with respect to professional development hours. I'm going to be sending certificates to everyone, regardless of if you require it or not. I'm just going to send them out as a standard process after each webinar. If you are part of a group listening in today, just make sure someone from your group emails me a list of those in attendance from the viewing party at your office. I think that's all I have in terms of administration. I'm going to introduce our speakers here, and then we're going to let them take it away. So today I'm excited to introduce Shirley Vaughn and Michael Harris with Davie Resource Group. We'll start with Shirley. Shirley is a business developer for Davie Resource Groups and works with federal, state, and local government and state DOTs. She specializes in large-scale tree inventory projects, urban forestry planning, and other assessments. Shirley is a certified arborist and municipal specialist, and she's a Hawkeye, gaining a bachelor's degree in geology from the University of Iowa. So she's happy to be speaking back in her home state, maybe, as a Hawkeye. She's joined today by Michael Harris, an urban forestry planner for Davie Resource Group as well. He's responsible for urban forestry plan development and a PhD candidate in urban geography and architecture from Kent State University, with a special interest in using GIS for land value assessments. So we'll kind of start the presentation here. If there are any sound issues, please someone just write in the question or chat box that we can't hear, or if there's any issues with the screen, just let us know. So thank you both, Shirley and Michael, for being here to take some time to share your thoughts with our members today. I look forward to hearing as well. So with that, I'll let Shirley take it away, and here we go.
Well, thank you, Ben. Mike and I are very pleased to have been invited to present to the Stormwater Education Group in Iowa. Like Mike mentioned, I did go to school in Iowa. I'm sorry, Ben mentioned. I went to school at the University of Iowa and have a bachelor's and a master's in geology. I am from Ohio, though, so I can't claim to be a full-blooded Hawkeye. I'm going to answer that question before it comes up. So first of all, yeah, thank you very much for having us. And Mike and I are going to jump back and forth and tackle this presentation together. This presentation is revisiting a publication that our company, Davie Resource Group, completed for the United States Environmental Protection Agency several years ago. I think it was around 2012, 2013, when these engineered systems that were designed to help grow trees as well as manage a volume of stormwater was developed. So I want to acknowledge our publication through the US EPA. And during this presentation, we are also going to talk about two other projects that Davie has worked on that focused on using urban trees to help manage stormwater. One is through a nonprofit in the Maryland area called Shore Rivers, and they worked with the town of Greensboro, Maryland, which is at the headwaters of two rivers that lead into the Chesapeake. That project was funded by the National Fish and Wildlife Foundation through one of their community improvement grants. So we want to thank our past clients for allowing us to use their projects during this webinar.
So we'll begin. I'm Mike Harris. Thanks for having us today. I guess a little bit to expand upon background. I'm an urban forestry planner here, have a undergraduate in environmental science with a specialty in land use and a master's in urban planning and still working on PhD perpetually. But I'm also a commercial real estate appraiser, so I've been brought on board to help with those aspects. For today, these tree benefits, our agenda, we're going to talk about why do we use trees to help with stormwater, how are we going to use the trees, and where to plant the trees.
And the reason that this webinar is focusing on trees is because trees do play a significant role in intercepting runoff and reducing subsequent water pollution. And I don't know the background of the individuals that were so kind to join us during their lunch hour, but when we speak about trees and the term urban forest, the term urban forest, that encompasses all the trees and greenery within a developed area. So that is both the public and the private trees. So if you hear us use the term urban forest, it's really about the trees in the built area of the community, which is where most of these engineered systems are designed to be used. So following with the agenda, we want to talk about why you would want to use trees to help manage stormwater. Mike?
Some of the tree benefits we can talk about, of course, is reducing air pollution. And one of them, of course, is noise pollution, and reduces energy costs and erosion and runoff. There's also discussions about either it's up in the air about reducing crime or not, but there have shown certain reductions in crime that have a medium amounts of greenery experience can reduce crime. We all know that a good walk in the woods can do us good psychologically as well, and so if we bring those greenery forest environments into the urban environment, we can reduce our stress levels and improve health and wellness. Another discussion is, of course, one that's near and dear to my heart is improvement of property value. And obviously this has economic agglomeration benefits when we start talking about the central business districts and we're adding street trees and things like that, the beautiful streetscape, and becomes more inviting and people feel more relaxed and have more interested in economics.
And so I know Ben invited us here to talk about the stormwater benefits, and of course that's our next slide, but we wanted to show you that trees are really provide more benefits than just stormwater management. They're an effective tool for improving the quality of life, as Mike mentioned, remediating pollution, improving public health. So along with populating your urban forest with the right trees to better manage stormwater, there's also other benefits that your community is going to reap. So now focusing on the stormwater related tree benefits. Trees manage stormwater in, we'll say three main ways. We try to keep it simple. Through erosion control, through interception of rainfall, and through pollutant uptake. So if we look at the diagram on the right-hand side of the screen, this is a diagram from the Stormwater to Street Trees guide. And you'll see a nice, healthy, mature tree and the way that it manages the rainfall with the precipitation being intercepted through the canopy. Some of that rainfall is stored in the canopy and later transpired back out. Thus, it never reaches the ground to cause erosion or become runoff. It is estimated that an urban tree can take up about 700 to 4,000 gallons of rainfall and runoff per year. And the variance between 700 and 4,000, of course, depends on the size of the tree, which we're going to talk about a little bit later in this presentation. So the water that is not intercepted by the canopy then falls through to the ground. Some of that rainfall is diverted by the roots. It helps prevent erosion, and it also, some of that rainfall that soaks into the soil is used by the tree, so it's taken up by the roots and then again transpired back. Anything to add?
Yeah, of course. There's a concern here. I think I'd like to start at the beginning and say, that, this is an artificial, the urban environment is an artificial environment. It's not the forest. It doesn't contain forest soils. It doesn't contain forest hydrology. It doesn't contain wetlands that are essential to reduce peak stormwater and, urban hydrographs versus rural hydrographs. We'll get talking to that in a little bit. But nonetheless, the discussion here is, okay, we need to create, if we're going to reduce flash floodings and things like that, this is just a part of it. And if we can make our environment look more like the green environment and more naturally, we can reduce these aspects.
So bringing in study results from the Shores River project that was in Greensboro, Maryland. This is a project that we'll touch on a few times throughout the presentation. And what you're looking at on the screen are the ecological benefits that Greensboro's urban tree canopy provides. So this is its urban forest, its public and private trees. These numbers were generated through modeling that our GIS department completed. And I want to bring your attention to the red circle on the third column. That's the annual benefits. So Greensboro had very few trees. They had several thousand trees in their community, so not a very large community. But in annual benefits, it was over $40,000. And the way that that's expressed is in stormwater structures that did not have to be built, and in carbon that was sequestered within the tree, and reductions in pollution. So just a few thousand trees provided considerable benefits in the town of Greensboro. And then one more study that I wanted to bring up was in Easton, Maryland, which is very close to Greensboro. It's over in the Chesapeake Bay watershed. We did a stormwater planting plan for the city of Easton, Maryland. And through some modeling that we did using their urban tree canopy data, we found that because they had urban tree canopy cover of roughly 25% of their land area, that runoff was reduced by about 0.51 inches. And I'm looking at the table at the bottom of the slide, that the time of concentration for an event was increased by 2.5 hours, and that the peak flows were reduced by about 600 cubic feet per second. And so because of the tree canopy cover of 25%, we're seeing what we want to see in terms of less runoff, that the water is being retained longer, so you have less peak flows. So the tree canopy is providing considerable benefits in Easton as it was in Greensboro.
Okay, so this is a discussion about, the trees. Everybody wants bigger trees. Bigger trees conduct more stormwater attenuation benefits, larger leaf trees. So we're going to talk about that study a little bit further on down here, a couple slides from here. But the most important part is how much soil, let's just talk about, we're not going to be planting sequoias in downtown, right? That's an issue. We have to be considerate about the tree selection, but also the soil volume. So how much soil to grow a big tree? So the maximum benefits, we want the largest tree in the space that we have. We're confined by space, so we need to know. So down at the bottom of the page, you can take a look and see there's a trunk diameter, and then there's a canopy diameter at the bottom of the page on the graph. And this shows a relation between how much soil volume you should have in your engineered systems. And this comes into consideration when you start discussing tree pits and size and where are these going to go, and if there's a cistern type system that's developed, or however you're going to hold your stormwater. So this is a consideration as well. And the next slide goes into the design. What all you want to say?
And the reason that we're talking about planting a big tree is for stormwater management. It's critical to plant the largest tree possible that your environment can accommodate. And when your environment seems constricted, such as in the urban forest, you have sidewalks, you have undergrounds, then in order to accommodate that large tree, that's when we need to look to the engineered systems that we're going to talk about at the later part of this presentation. So the focus is on growing a big tree in an urban area and figuring out how to get that done.
Oh, is that the next one, or did we go past it?
Which one do you want?
Go to the next one. Oh, okay, there we go. iTree design. So iTree, if you're not familiar with it, is U.S. Forest Service in conjunction with the Davey Institute and a couple of other groups where it's a free online publication, and this is just a projected benefit discussion that I made up this couple months ago, and this iTree design, you can input the types of trees and the size of the trees that you want and the location that you want. And there are certain parameters that you input this, and it will tell you the stormwater runoff savings. It'll tell you the amount, the price amount, and also the gallons of rainfall that it's stored. Or reduction. It also talks about carbon dioxide and carbon sequestration and also energy savings, things like that. This is an iTree design product. If you could go back to the other one, the one before, the hydro. This is a little bit more in depth. This is an iTree like the hydro process. And as you can see, the inputs and outputs, it's a model that was based on the USGS model years ago for the soil runoff issues. And this is inputs and spatial distribution. So you input the information, and as you can see on the left side there, they're talking about the different layers of the GIS. So they have a hydrology layer, a topography layer, a soils layer, and an urban layer. And they're adding all these layers together and to put out your outputs to give the next slide, which is the design. But these are functions that are freely available online by the U.S. Forest Service. So you should get to know these. They'll help you.
Yeah, and the reason that we're mentioning the iTree and the free tools, they're peer reviewed. They have about probably 15 years of research behind them, and they're getting fine-tuned every day. And one of the challenges with using trees for green infrastructure is I don't know that they've yet been quantified. I don't know that we can say a large sycamore tree will provide X benefits. I do believe that the Forest Service and maybe even EPA are working to do that, to make it better for planning purposes and for stormwater managers to justify adding trees to their designs and to get credits for that. So that unfortunately is still, I wish I could say it was some results we could present today, but I do know that it's they're working on that.
Well, it's incremental, as computers improve and the complexity of the equations improve and how these are developed over time, they get better and better. So I definitely invite you to take a look more into iTree. We're going to pick those out.
Right. And iTree is great for public education for the benefits that trees provide.
Yeah, it's free. You can go take a look. You can talk to public officials and discuss this. They can pick out the trees in their own backyard, and you can talk exactly about the benefits that those trees provide and stormwater related benefits.
And so now as we want to focus back on growing these large trees in the urban forest, to grow a large tree, one of the biggest consideration is the soil. And the soil matters. The type of soil, how much soil, it's
right. Well, yeah. One of the issues here, urban soils are less than optimum. I mean, when we go into a site and we're going to construct new buildings, the first thing we're doing is taking down the trees and scraping off the topsoil, and what's left is the residual subsoil horizons. And this is a concern. So they may have content as far as mineral content or really heavy leached out, the organics are gone, and so they have root compaction concerns. You can't just plant these trees in a clay environment and expect them to perform. Just throw good money after bad. So part of that is taking a look at what you have in your urban soils, and it's going to help also from the stormwater benefit, where you're going to look at percolation values and infiltration rates and things like that. But on the other hand, you need to feed the trees. So there's a fine line between fertilization of the tree, soil compaction, stormwater attenuation, and pore space. So you're pulling all those together. The big concern is high calcium construction debris in urban soils, high salt content, from the Midwestern or Northeastern areas where we're using salts on the road. These are growth inhibitors. They'll kill trees, definitely conifers if you see it. Sand and pore space is a big consideration. So the next slide talks about the right tree in the right place. That's the whole thing. If you want to open that next page. So the right tree, the right place. So we have the best overall performing. This was an interesting study. So these went over 3 types of study, looked at 3 different trees. One was the sweet gum, and one was a London plane tree, and the other one was a silver maple. And the best overall performing for stormwater attenuation was the sweet gum, and that's the one on the left, the far left with the little spiky ball. That's a sweet gum, and in the middle, that's a sycamore, but here it's a Platanus X acerfolia, so that's a London plane tree, and you see that all over the place. That's a pretty common street tree. And silver maple was ranked best for growth rates and increase in leaf area, but a lot of urban foresters don't really appreciate. They kind of go more towards a red maple than the silver maple. Silver maples tend to shed a lot of stems as they grow, and so it's a little bit of a higher maintenance tree. But the sweet gum, it's kind of a slower growing tree, but it's good. It's the best that they rated for that. The whole discussion of right tree, right place. I put this picture when my son and I were out for the scout camp, and they have on the lower left-hand side, this is an armed honey locust. So I thought that was kind of perfect. They had it at the scout camp, and this whole mantra of right tree, right place at the right time scenario kind of came into play, and just wanted to show that, just to reiterate that important point. What's the next slide here? Do your tree selection tool? Yeah.
So as Michael's been talking about the right tree in the right place and about the soil types, and I heard him mention a key term, which was soil compaction. When we focus on growing these large trees in urban areas, a lot of the engineered systems, which we're going to start talking about pretty soon, the stormwater tree pits, the suspended pavement, the structural soils, the permeable pavement, their focus is to provide almost a vessel for a soil structure that's not compacted. And then they have an added benefit of creating some pore space that helps accommodate the stormwater. So key to growing the big trees is limiting the compacted soil and having a volume. Key to managing stormwater through these engineered systems goes right hand in hand. It's having that volume, that space, and that uncompacted soil. So the next slide that we want to talk about is just a tree selection tool. And as managers of the urban forest, tree selection is very important. For stormwater managers that want to use trees to augment their existing systems, knowing what tree provides the correct benefits is important. So I'm going to try to show a spreadsheet that we created for a client in Florida to help them understand which tree is the best tree for applications, such as to use as a park tree or to use in a retention pond, to provide fall color, or to be in a space that's prone to droughts. Also, trees that perform best in commercial districts versus residential streets. Trees that require good drainage versus trees that can tolerate flooding. So having a tree selection tool for being a stormwater manager will help you in your planning processes say, wow, this tree is going to grow medium size, fits my space, it can tolerate flooding, and it's a good choice for this commercial district that I'm working in. So it really helps narrow down so you get the most bang for your buck. And at the end of the show. All right, so what we have on the screen now is a spreadsheet that we, again, created for a community in Florida. So these are southern species that you can see we have the botanical name, whether it's a native or non-native tree. And then based on the criteria that our client wanted, you know, whether that tree was appropriate for a parking lot setting, whether it was appropriate for a street tree, retention pond, whether it provided some needed function as a screen. Then we also gave information about that tree in terms of its tolerance for drought, for soil salt, soil pH, pest resistance. So all the information that they would need to select the right tree for the right place. If they wanted to plant a tree in a retention pond that was an understory tree, they had some selections they could look at. So they could say, well, maybe this wax myrtle is a good tree. And then they could go look at the other criteria to make sure that the tree fits the spot. So a tree selection tool is valuable for the urban forest manager, but we also think it's good for the stormwater manager, especially when you're going to be selecting trees to go in engineered systems that have some special design considerations. So back. Mm-hmm. All right, no, current slide. Whew. All right, dang it. All right, I think we're back to where we started. So next slide.
Mm-hmm. Okay.
Yep. No, go ahead.
Tree, okay. So a tree inventory, for those who may not know, is a physical inventory that's taken by multiple individuals, mostly certified arborists that go out to take a look at it, in our case, as far as DRG goes. And it's on the ground collection where the arborist is physically on site and inventories each individual tree and takes a look at the species. They also evaluate risk. They look if there's any obstructions. We talk about power line. We talk about heights within power lines. We talk about any other conflicts that may be, sewer on one side of the road, storm sewer problems, things like that. Any kind of conflicts, they look it over. They also look at the tree health that's evaluated with it. If it's had any young tree training or if it needs to be pruned, is there a priority pruning? We look at stumps or potential planting sites. That's all in the tree inventory that's done. And this can aid stormwater as well. You can look at areas where you are having, you know, another layer of stormwater concerns, or you have public problems where you know exactly where they're having runoff concerns, and overlay your tree inventory and take a look and see what's the best option for that area.
Right. And so why we're presenting this information is to show you, you know, if you're interested in planting trees to better manage stormwater or use these engineered systems to as green infrastructure with trees, the next two studies we're presenting, this tree inventory and the urban tree canopy assessment, help you identify the places, the best places within the urban forest to plant trees. This is a project that was part of the Shores River. So their tree inventory is showing two different colored dots. You have a yellow dot and a green dot. The yellow dots are vacant planting sites, and the green dots are the inventoried trees. So that information was utilized along with information from an urban tree canopy assessment. So this is a top-down
Hey, Shirley,
view.
could you real quick minimize your GoToWebinar panel? Sorry, we can see that. There you go. Thank you.
Oh, no.
You're good. That's good.
Is it good?
Yep, we're good.
Okay. All right. Thank
We
you.
didn't see any difference on our end. We see.
Okay. So the urban tree canopy assessment. So this is a top-down view, and what you're looking at are different land cover classes that are symbolized by different colors. So tree canopy is the darker green color, low-lying grass and vegetation, so pervious surfaces, the light green color. And then what's pretty important for stormwater management, you'll find out, are the impervious surfaces, I'm sure as you're all aware of. So this study, which is mapping out the tree canopy throughout this community along the Choptank River, along with the tree inventory data, which maps the vacant planting sites. Uh-oh, I'm not forwarding. Having a little trouble forwarding here. Hold on.
We'll go to the next.
There we go.
Yeah.
Along with the vacant planting sites, which if you can look over on the left-hand side of the screen, that's showing the tree inventory data with the yellow dots as the vacant planting sites, the green as the trees. Oops, the green is the large vacant planting sites. And then on the right-hand side, that's a combination of some modeling that we did using the urban tree canopy assessment data and the tree inventory data. I did a little graphic up in the upper left-hand corner. Using GIS, you can overlay. Sorry about my computer here. That's where I gotta go.
Where'd you go?
Sorry, Ben. Got into a funny mode.
Yeah, that's where.
All right, I apologize. I should have let Mike be in charge of the computer controls.
We're good.
When I switched to Excel, I'm in a different mode here. I'll try to do better. So back to the slides. So the tree inventory data was used alongside GIS modeling to identify areas within the community, if you look over on the right-hand side, that most impacted stormwater management. The areas in red are areas that were recommended for tree planting of the highest priority. And on our next slide, if I can get to it, I'm a little scared. On our next slide, you can see that the highest priority area, which is in red on the right-hand side, corresponds to the diagram on the left-hand side to an area where there's a parking lot, which is you see the black arrow with the pink.
Impervious surfaces.
Yes, pink impervious surfaces is a parking lot. Then directly next to that, we have an area that does not have a lot of tree canopy cover. So in terms of planting trees, installing these engineered systems, maybe parking lots that have a reservoir underneath with structural soil in it, that would be an ideal candidate to help prevent that flow going towards the river. Looking at the map, you'll notice on the diagram on the right, even though the river has planting sites near it, they're categorized as more moderate. And that's because when you look over at the canopy cover, you can see that there's a nice buffer there. So doing this type of modeling really helps you identify areas within your community where installing engineered systems and planting trees can make the biggest difference. So this is just a summary slide. I'm going to go over it real quick. So this is the inventory data overlaying with that previous risk assessment. And so now what this community has in Greensboro is they know where they should plant trees to make the biggest impact to manage stormwater. And if they install these engineered systems, they're going to get more bang for their buck because the engineered systems really augment the function of just a typical tree in good soil. And then one final discussion about a tree inventory that I thought was very interesting. This is a study that we did for Easton, Maryland, several years ago, and they completed a tree inventory. And what was really, really cool about the directions and the specifications that they gave us was that they directed our arborists to collect information about areas that were lacking trees or areas full or partially full of cement as a vacant planting site. So Easton had a vision many years ago in their urban areas to retrofit areas to accommodate trees to help manage their stormwater. So it's thinking a little bit out of the box if you're doing some type of planning, collecting some type of data to plant trees, to think forward and go, well, what if we added a bump out? What if we put in a linear tree pit and remove some cement? Let's go ahead and collect that information and think ahead of the box.
So I talked a little bit before about soil and, you know, right tree, right place, and we're having those discussions, and that's important. I kind of go back to that Stephen Covey's 7 Habits of Highly Effective People. And one of them is always begin with the end in mind, right? Not sure what number that is, but I remember that being in there. It's been a while since the book. But nonetheless, why design matters. Begin with the end in mind. What are we trying to accomplish with this tree? What do we think it's going to solve all the problems of the stormwater? Obviously not. It can't. This is just a benefit on top of the rest of the infrastructure that's involved here. A couple of these design, I mean, on the right, we've seen this a couple times through this presentation. This is kind of the hydrologic cycle discussed, you know, where you're having precipitation into through fall, and the whole goal is the stormwater attenuation, right? So we're trying to slow the flow. And that's what this design is discussing, all these different types, the soil under the sidewalk, this pore space. If you notice the one on the left, this is what happens for a tree that's in a bad condition. You see the crown of the tree is decaying, and you're seeing a loss of leaves and a poor health overall. I keep going back to the same thing where it's not the forest, it's an urban environment. There's a lot of stressors on the tree. They're not going to live as long. They're not going to be as big. They're stressed all the time in that high-end environment. Just think of like going to school and it's finals week every day for you. So that's what the deal is. It's the same thing as why design matters. So if you kind of think of it from that perspective and you're looking at stormwater pools and where they're going to go, and if we combine this with pervious pavement and we think about the right tree for the right location, it's going to help us in the long run. Let me go to the next one here.
Okay.
So here's actual discussions. So there's a recent study in New York City where they looked at all the different tree pits. If you look at the lower left picture, you'll see numbers. You're missing the A's and the D, but you'll see the pictures there. They looked at different tree pits designed in New York City, and they found that actual tree pit guards, the ones that were guarded, actually had the ability to people walk on. They were associated with higher filtration levels. The larger tree pits were, you know, they had so much with the mulch issues too. So if you had something like B, like letter B, if you look at that, that's not really the best case scenario. There is some stormwater here, but they found that a lot of that would run off right into the street instead of their lower filtration rates. And going in hand with that is this mulch is not a positive factor in infiltration. So be careful with the amount of mulch that you use. So their conclusion was the larger guarded pits with no mulch and designed soils that we talked about, pore space and aggregate soils and things like that were coming up, or were the best performers. That's something to think about. And up the top left one is an interesting thing. The top right is the finished product, and the top left is where they're installing this vaulted tree pit. And they're showing where the stormwater is going off and it's feeding into the tree. The lower right-hand corner is just kind of showing an exaggerated where the water's running off. This is almost kind of almost looks like a, not so much a pit, but this is more of along the lines of these the lines where they have the like a almost a bioswale, but it has vaults on the side. So this is, it's not contained, it's not a full vault. This is a partial vault because it has sides on it, but you can see down below the roots are growing down into the soil. So it's one of those 3 phases. We can go on the next one because the next slide talks about that, different types of tree pits. So this one's fully enclosed. This is, I guess I kind of think of this as more of a cistern type scenario, maybe not a full-blown cistern where you're having it down below the trees, but a scenario where you have an overflow, you have a pipe where there's percolation going through, and you have you know, your perf pipe down below that flows into a bypass, but you're just trying to slow the urban flow. That's stormwater attenuation. They're showing, again, this is the tree pit, the fully enclosed one. It's a whole vault, so that it's essentially a case, like a concrete case that they're putting in the ground. It's a prefab scenario, and the tree grows in that. Of course, you know, the problem is there's going to be issues with fertilizer and upkeep of the tree. The tree gates and the clean outs make sure that the tree grate is cleaned. So that adds to the man hours of the project. You want to go to the next one for me, please? Oh, okay, this is going to discuss the structural soils. So this is a structural soil. They use these in some of the tree pit scenarios. And the contrast is, instead of having just urban clay soils that I had discussed before, we're adding granular angular rock that's crushed, that develops an uncrushable pore space, and this 30% pore space. It's good for draining. Some companies add like a gelatinous type of matrix into it that will retain water longer. You know, it's designed to be where soil compaction, sidewalks, that kind of thing, things where you might have deliveries and things like that. So you don't want an exposed critical root zone where you're going to have concerns about root compaction or damage to the tree. So this scenario works out well. The picture down below shows a finished product where you're seeing it's almost like if anybody's familiar with geology, it's almost like a conglomerate, right, Shirley? Like a conglomerate thing where you're having, instead of rounded pebbles, these are angular, and then the matrix is this like a silty soil matrix. Okay. Here's a discussion that's from the Cornell University, this Urban Institute. This 1.5 inches and the depth of the reservoir needed. That's all. They all can be found online. But I thought that was an interesting chart to give the size of the rain event, how many inches you need, and how many soil that you can retain in the depth in your tree pits.
And so typically a structural soil is good for parking lots and medians and plazas. It can be incorporated when you're redeveloping areas. It doesn't necessarily provide the most soil, but it does provide the opportunity for a very large reservoir of rock that can accommodate a volume of stormwater underneath the parking lot. There's been applications, especially up in Ithaca, New York, where they've retrofitted parking lots to have a stormwater reservoir comprised of structural soil underneath the parking lot, and then have the top be a combination of the permeable pavements and grasses to allow for the infiltration. So the end result has been a parking lot that's growing nice large trees, as well as a parking lot that's storing and managing a volume of stormwater.
Mm-hmm. I mean, I'm concerned. I like this idea. I like the structural soil. I think it's functional. Off the top of my head, I'm concerned about fertilization and the organics that's involved here for the tree. So, I mean, we're already in a stunted environment, and we're going to keep certain organics away from it that it needs. So I think that, you know, the discussion here, it's important, it's functional, but also there's going to have to be maintenance involved here. It's not going to be, we're just going to plant the tree and everybody feels good and we're just going to walk away from it. There has to be maintenance involved afterwards, which includes some kind of fertilization so the tree's functional. So we do get the return that we're trying to plant.
That's a very good point.
Yeah, the next one. It's the open design. So this is what I was discussing a little bit earlier too. This is an open design, not a vaulted design. This is the opposite. So they're showing kind of a clay. They show structural soil, but you could do a clay organics matrix, something to facilitate root growth. It's not going to do well in soil compaction issues. You're going to have trees that are not only stunted but shallow root zone problems. So they're going to be subject to ice storms, wind throw damage, things like that. So you want a structural soil where the roots can grow down in, and there's other options I think that we have in the other figures too, but we can go to the next one. Yeah, this goes in this, the next one's suspended pavement. Yeah. So the picture on the right is a product called a Silva-Cell. And what this is a plastic supported matrix, like a structure, and then thrown into, you fill in the soil here. And the idea behind this is a non-crushable, still the same kind of thing as structural soil, because we're trying to get away from compaction. And this is the same scenario. This helps infiltration, but also creates pore space. And so there's stormwater attenuation, but yet the roots can grow. It's commercially available. The one on the left is kind of a interesting rendering of, of almost like an engineered bioswale here. It shows. This is the one from the EPA, right? The one on the left, that one.
Right,
yeah. So, yeah, go ahead, did you?
So the suspended pavement, that's been in use for quite a long time. The city of Charlotte's had suspended pavement, I think, for 15 or 20 years in their downtown area. Lots of different brands available. Silva-Cell was the one that kind of came into the world of arboriculture. I would imagine for stormwater management, you're familiar with a lot more makers of a similar product. So we're in no way endorsing Silva-Cell, just one that we are probably most familiar with. Of course, James Urban has spent a considerable amount of time helping the arborists to understand how to help trees grow large in the urban environment by providing these underground structures that limit the compaction. These suspended pavement systems are being heavily used now and often being written into codes for development. I was just in the city of Miami Beach, and they use Silva-Cells in almost all of their installations in order to provide that space to have room for soil that's not compacted, as well as managing some stormwater runoff, which is a huge concern in the city of Miami Beach.
Oh, okay, so this is deep. Oh, this is another type of Silva-Cell scenario, huh? Two Silva-Cells, okay, for that. But this is, you can see here in this rough drawing, yeah, you can see the pictures where the roots grow down in, and there's a top to it, there's a bottom with the pillars, and the top goes on top of it with the steel reinforcing tubes.
Right, and they can be stacked anywhere, depending on your desired environment, anywhere from a single layer up to 2 or 3 layers deep in order to create the volume that you need to manage your stormwater. This was just a study that I wanted to highlight here, done in 2015 in Wilmington, North Carolina. And what the findings of that study was, they checked on 2 Silva-Cells, and they found that it helped them manage both tree growth, so they reached their end result of growing a nice large tree, as well as their stormwater management goals, noting that sediment and heavy metal concentration decreased significantly at both of their 2 test sites. So this product was able to grow the large tree, which is helping intercept the rainfall, as well as providing that volume of soil, which is allowing for more of the pollutants to be removed. And it was successfully retrofit into an urban environment, which is pretty key.
Oh, this next slide, I thought that was really nice looking.
This
one picture in kind of in the middle in the center is an interesting engineered bioswale scenario. And you can see there's a pervious pavement down on the left-hand side of the picture. I'm on the one in the middle. where there's looks like a Toyota there on the right-hand side, and in between, and so we're absorbing the runoff and conducting it. But that's a good quality where you're integrating, an herbaceous layer, a mid-story layer, and a tree layer into the urban environment to control it. The top left picture is just is actually a driveway of someone's driveway where they had the pictures of the bricks that go in between, but then they still have to mow it, but it's a scenario where it works. And top right is a block of pervious pavement showing the flow rates between ½ an inch and 3 inches per hour.
And in terms of urban forestry and growing the large trees in these dense areas, the pervious pavement used in conjunction with the suspended pavement, used in conjunction with the linear tree pits or the stormwater tree pits, as well as the structural soil, really helps increase the infiltration. One thing that you do want to note is that you have to make sure that there's proper drainage in your engineered system so that you don't create an environment that's going to retain too much water and cause flooding, which will harm the tree. So having the system properly designed to have infiltration as well as storage and then an outflow is key. And I know Mike and I kind of shied away from presenting any real engineer drawings or a lot of technical specifications because it's unlimited probably the designs that you could do by incorporating these different systems in various ways.
Mm-hmm. Your flow calculations are going to determine a lot of that. Yeah, here's different really quick here, just some interesting discussion here. This is a kind of a rain garden. So in the north, they call them rain gardens or constructed swales. In the southern area, they call them swamp gardens here on the right-hand side with this, the beautiful bald cypress there. And I threw in a couple of tree species to consider. A tamarack. There's some of these, these conifer as well, and the birch is a deciduous, but there are conifers that do like wet feet. Not all of them do. Most of them do not. They certainly aren't salt tolerant, but it's something to consider. Especially, I'm a big fan of bald cypress personally. But when you start talking about constructed wetlands and you're in bioswales and things like that, and you're looking for stormwater retention, just consider trees as part of the model.
And I think one of the key take homes from this slide for me is just looking at the amount of space that's required to successfully implement some of these engineered systems. At the lower diagram, we have some large trees there with that swale. It's not a small medium, so we have a nice volume of soil, and that's what's accommodating those large trees. And then in the upper center diagram, I have a very nice kind of rain garden in between the sidewalk and the curb, but it has a nice amount of space in order to manage the volume of stormwater. You just can't get away from space.
Just to go, I know we're running out of time here, but Shirley, what do you think about these trees on the left? You think they're running out a little? I mean, this one here on the right, I'm looking at the lower left picture there. And the ones, do you feel that they're too close to the parking lot? Are we in the critical root zone here? This one over here, I'm not sure what's going on with the one that's right next to the right of way. Interesting, nonetheless.
I guess
the tree condition.
It depends if it was planted
right.
before or after that curb came in.
Right tree, right place. Right tree, right place. Okay.
All right, so we've got, I think, one or two more slides. I know we're running out of time. Mike was going to talk about buffers.
So you're creating buffers. This is going back into the constructed wetlands discussion. I mean, the goal is to smooth out these storm hydrographs, and we're reducing the risk of flash flood. There's a few studies going around about daylighting streams and some vacant lands and things like that. But we want to cut that down and make that. Is there the one? Is that one thing is adding compatible trees for suitable wet conditions? That's what I just talked about before. But just consider trees.
So in summary, as a stormwater manager, I think you have an opportunity to make trees part of your plan. They're certainly not going to manage all of the rainfall and the runoff that your community is faced with managing. But they have additional benefits besides just helping reduce erosion and runoff. The social benefits that trees provide are very important. The fact that they can also help reduce the urban heat island, as well as your carbon footprint, in addition to stormwater, make them a really good investment in your community.
Mm-hmm. Oh, of course, I have to go back and talk about property values, community perception in general. People want to shop in areas that look nice, and trees add that. And if you can put that as part of your stormwater plan, more benefits for everybody.
Yeah, and I can't stop hammering on the point that try to use the engineered system to create a space for the largest tree possible.
Right.
Provide that underground volume that manages both the tree roots successfully as well as the volume of water that you want to manage. It really always gets back to what are you tasked with doing, and how can you make trees part of that to help offset some of that stormwater. And I will apologize one more time for fumbling through the slides.
No worries, no worries.
Can you expand that, Ben? We have any questions?
Maybe.
Yeah,
Feel free to touch
I
anything.
actually don't see any have come through yet, but of course, for the audience listening, if you have any questions, write them in the chat box right now. I'll kind of lead with the question I have. I thought the mulching discussion was interesting with respect to what was almost said is less is more. From a urban forestry tree perspective, and your guys' expertise on getting trees to a place where they can succeed, what is recommended types or schedules? And this is going to be dependent, of course, on different scenarios, but what's your expertise on mulching from the onset of planting?
I kind of loathe mulch. And it's not because the mulch doesn't provide a purpose. There is a purpose to it. Obviously, it keeps down on weeds and things like that, and it retains moisture. There's some benefits, but oh man, it seems like 7 to 8 out of 10 times it's just put on wrong. We jokingly call them mulch volcanoes, where they're coming out and you see these stems growing out of the soil. They've buried the root flare of the tree, which you do want to see. You want to see the bottom of the tree, the basal part of it. That's why it grows that way. It's supposed to be that way. So if you cover that up, you're suffocating the tree. I mean, it's good to have. What you want is a donut, okay, essentially around it, and you want to have a base built up, but you don't want the mulch like directly piled up on top of look like a volcano. You don't want like a volcano with a tree in the middle. That's not what you want. You want a donut with some, so that it just kind of holds the moisture in, retains it, and it just kind of helps it go through. Because when you really, it's already stressed, right? Trees are already stressed. It's in the wrong environment. It's not in forest. Secondly, you're putting in a scenario where it's already stressed too, because it's planted. So you dug this tree up out of a nursery somewhere, chopped off a large percentage of its roots, threw it into a ground somewhere, and now you're overwatering it and you're suffocating it. I mean, we have to invest. We have to think smart about our money. That's just my opinion on it. But if you do it the right way, it performs the function it should.
Sure.
Yeah, I would think industry standards are 2 to 3 inches of mulch. Don't touch the trunk of the tree, as Mike explained with the donut. And then, the added benefit is having less mechanical damage. A lot of our young trees, especially in urban environments, suffer tremendous consequences from line tremors and being hit by equipment. So having a nice circle of mulch does help protect that tree and give it a better chance of not being injured during ongoing maintenance.
Mm-hmm. Sure. We got a question here. It reads, how do you respond to folks who argue tree roots in urban settings will find ways to clog our old sanitary sewer pipes, i.e. clay tile with poor joint seals, and then they end up asking the question or proclaiming that we can't have street trees for that reason? How do you respond to that?
Well, you mean, like I said, right tree, right place. You have to pick the right tree with the special species. And then if you are retrofitting, consider the vault scenario where you're locking the tree roots, so you have a smaller tree. You're getting the benefits, the aesthetic benefits of the tree. You're getting a little bit of stormwater attenuation, and you're also getting a scenario where you have, what would you want to add? And you also get a scenario where you're restricting the tree roots in that area. So it's probably a little bit more cost up front. I mean, yes, of course, it's easier to just plop a tree into the ground, and you're definitely going to have problems with clay tiles. I mean, and even in Cleveland, I know they still have some wood sewer in downtown Cleveland. That's definitely an issue. I want to know, does that answer the question? I mean, I'm not trying to dance around it. I mean, obviously that's an issue. I mean, you're going to have tree roots grow. If you can restrict the tree size and you can restrict a vault size, you should be able to alleviate some of those concerns. Like I said, you don't want to plant a sequoia in the middle of downtown, right? It's an issue.
And I think, tree roots typically grow in the top 18 to 24 inches of the soil. And if you can plan your streetscapes in order to minimize those conflicts, that's where you'll be the most successful. Tree roots are going to seek oxygen, and yes, they are going to come into conflict with sidewalks, and they are going to find their way into pipes. I think that's a reality. But the better that we can plan our design to minimize that by trying to create the space the tree needs so it doesn't have to go elsewhere, you'll be most successful. A lot of our clients will map their trees and create a GIS layer of those tree locations and of their vacant planting sites. That was the tree inventory we illustrated earlier. But then they can overlay that information if they have undergrounds, if they have the locations of where their sidewalks are going to go, so they can create a kind of a living GIS database in order to pick the best locations to try to minimize future conflicts. And that's really the best you can do for any engineering.
I mean, honestly, I mean, if you come out and it goes out, I mean, I'm not going to sit here and say that, well, you know what, the tree always needs to stay there and you just need to figure it out. I mean, if the tree is creating conflict, I mean, there are better spots available. Maybe there wasn't very good design back in the day, and so they just planted it to plant where it was because it felt good to plant a tree. So if it needs to come out, it comes out. I can't sit here and say I'm against that.